Hello, this is Geometry Unit 2 Video Notes number 1. Today we're going to talk about lines intersected by a transversal. We're both going to talk about parallel lines and non-parallel lines, and they are all pairs of lines are going to be cut by a transversal. So in this box here, in your vocabulary notes or in your notebook, you can document the vocabulary that we're going to be using today. So I'm going to be saying words like parallel lines, transversal, corresponding angles, supplementary angles, linear pair, alternate interior angles, alternate exterior angles, consecutive interior angles, and vertical angles. So make sure that your notes are titled Lines Intersected by a Transversal, Unit 2 Video Notes number 1, and we can get started. We have 3 exercises to do in this video today. Exercise 1. In your notes, please document and copy down this figure, and I will read and annotate the instructions. In the following diagrams, line N and M are parallel, and then they give you some symbols. So this must mean parallel, 2 lines. And they're cut by a transversal line R. Here's line R, and this is transversal. Angles have been numbered to make identifying them easier. Thank you. Give all corresponding angle pairs. What is true about their measures? Well, corresponding angle pairs, if you don't know, you should refer back to the PDF texts that were posted after your Unit 1 exam, and you took notes off of that. We called it a reader. If you don't know these weird words that I'm saying a lot, you need to go back and research using those readers and take notes on that. So let's list our corresponding angles. If I have the top left, I'm looking at, it looks like 2 T's that are lined up here, or 2 X's, and the top left hand out of both of those, if I'm just looking at this square and then this square, the top left hand, well, those are equal because they're corresponding angles. So angle 6 is equal to angle 1. And then we have the top right hand side. So angle 7 is equal to angle 2. And then we have the bottom left hand corner. Angle 5 is equal to angle 3. And we have the bottom right hand corner. I'll put 2 lines here. So angle 8 is equal to angle 4. And what does this mean about their measures? Well, this means corresponding angles have equal measures. And this is something that we're going to use in the future for a problem-solving tool. When we look for missing angles, we can actually use corresponding angles to gain more information. Same with the words alternate interior angles. With our alternate interior angles, they come in pairs. And then what is true about their measures? Well, I'm going to take this away now. Okay. Alternate interior. So we have 5, and on, I think these yellow boxes are confusing now. So we have 5. We need angles that are on the inside. So already we're just looking at these angles here, the angles on the inside. And we need to alternate the side of the transversal that it's on. So on the other side of 5 is angle 2. So angle 5 is equal to angle 2. And then we also need angle 8 and angle 1. They are on alternate sides of the transversal, and they are on the interior of the parallel lines as well. So what does this mean? Well, this means that alternate interior angles have equal measures. Go ahead and file this in your toolbox for missing angle tools. When we give you all those problems where you have to find the angles, this is something that's going to come in handy a lot. For exercise number 2, I'm going to annotate this problem. So it says in the following diagram, you're going to have to copy this diagram in your notebook, K is parallel to H. So K is parallel. That's what this little, these 2 little lines mean, parallel to H. Which of the following is measure of angle 1? So we need to find this angle 1. And looking at this figure, we have a couple of things going on. I see some parallel lines. I see a couple transversals. And we'll see how this helps us out. So it looks like to find angle 1, I do see a triangle here. And I do know that triangles have to add up to 180 degrees. And so we can prove this using our alternate interior angles and our corresponding angles. But let's zoom in and take a look at this guy here. This is a straight angle, and these two angles are linear pairs. So that this must be 180 minus 126. Whoops, that should be a 6. Okay, so this should equal to 54 degrees. 54 degrees, if this is 54 degrees here, and I have a transversal cut off by this line here, then this must also be 54 degrees. I'm checking my work to see if this makes sense. And if this is 54 degrees, then I also have a corresponding angle. This angle here corresponds with this 42. Why does it correspond with this 42? Well, we have our highlighted parallel lines, and now we have this transversal over here. So this transversal means that 42 and this angle up here are corresponding. So we have 42 degrees. So just like we have a triangle right here, and we can add up all three angles to 180 degrees, we also now have three angles that add up plus angle 1 that adds up to 180 degrees as well. So just like triangles add up to 180 degrees, and this straight angle is the sum of all three of these angles. So if we add these all up, we have 42 plus 54, which is equal to 96. Oops. Plus angle 1. This is our variable, angle 1, which could have been anything. I left it as angle 1, which is confusing, but how about I change it to an x? So this becomes x, this becomes x, and this becomes x. And then 180 minus 96 would be 84 degrees. And that was like a long roundabout way using corresponding angles and alternate interior angles, but we also were able to practice our vocabulary as well. For your final exercise, go ahead and copy down this figure in your notebook, and we're going to identify the relationship between each pair of angles. And when it says relationship, these are the vocabulary words that should pop in your head. Scrolling up. Okay, at the top of your notes, you had these words written down, and corresponding angles, supplementary angles, linear pair, alternate interior angles, alternate exterior angles, consecutive interior angles, and vertical angles. These are all things that describe relationships between angles, and when we ask you for relationship between angles, these are the words we're looking for. They tell us information that we don't already know, which is helpful. That's why it's helpful in problem solving. Back to the third example. What is the relationship between two angle pairs? Well, what's the relationship between angle 7 and angle 8? Looks like they are on alternate sides of the transversal, and they're on the inside of the parallel lines. So these should be alternate interior angles. What about for B, angle 2 and angle 7? Even though these are not parallel lines, the big thing here is that these are not parallel. However, well, there's still information that can be told about these two angles. I don't know why it's doing this. These are still corresponding angles, even though they're not parallel lines. It doesn't mean that they're equal in this case, but it just means that they're corresponding. What about angle 1 and angle 6? Well, angle 1, angle 1, and angle 6. These are on the exterior. The first thing I noticed, they're on the exterior sides of these lines, and they are not corresponding because they're not both in the top right-hand corner. Instead, they're alternate exterior angles. Alternate exterior angles. So they're on the outside and they're not corresponding angles, so they are alternate angles. They're not supplementary. If these were parallel lines, then they would be supplementary. The point of this is that these are not parallel lines. Okay, what about angle 5 and angle 7? Last one. Angle 5 and angle 7. Angle 5 and angle 7. Well, they're on the inside of the angles and they're not corresponding. So these are probably the alternate interior angles. Okay. In this video, summarize the most important parts and indicate it in your summary, and then bring your notes to class. Bye!